Have you ever heard about the word spin? It is not actual spinning. The term spin can be misleading as it doesn't imply that particles are physically rotating or orbiting. It's a fundamental property of quantum particles. What is spin? At its core, spin is an intrinsic property of fundamental particles such as electrons, protons, and neutrons. It's often visualized as if the particle were literally spinning on an axis, but this is a classical analogy and not entirely accurate. In reality, spin is a quantum mechanical property that doesn't have a direct classical equivalent. Why is it called spin? The term spin arose from early attempt to explain the behavior of electron in magnetic fields. Scientists observed that electrons behaved as if they had an intrinsic magnetic dipole moment, which is typically associated with a rotating charged object. While this classical analogy helped in the initial understanding, it's crucial to remember its limitations in the full quantum mechanical description. Characteristics of spin: intrinsic angular momentum, quantized, vector quantity, not a classical rotation, related to statistics. Intrinsic angular momentum. Spin is a form of angular momentum that particles possess even when they are not moving through space. It's an inherent property like mass or charge. Quantized. Spin is quantized, meaning it can only take on specific discrete values. For example, an electron has a spin of half. Other particles can have different spin values such as 0, 1, 3 by 2, and so on. It is a vector quantity. Spin is a vector quantity, meaning it has both magnitude and direction. The direction of the spin can be up or down. It is not a classical rotation. While the name spin suggests rotation, it's important to remember that a fundamental particle is not a tiny ball spinning in space. Spin is purely quantum mechanical phenomenon with no classical counterpart. It is related to statistics. The spin of a particle is directly related to the statistical behavior of collections of those particles. Particles with half integer spin, like electrons, protons, and neutrons, are called fermions and obey Fermi-Dirac statistics, which means no two identical fermions can occupy the same quantum state. Particles with integer spin are called bosons and obey Bose-Einstein statistics, which allows multiple bosons to occupy the same quantum state.